Alright, welcome to my second video on proportion or variation, depending on what you like calling it. And now in this one we'll look at inverse proportion or inverse variation. Here I've got a graph, and let's talk a little bit about how I'm going to use this. So let's just say this is my number of men, but let's call it people in case there are some. Because it could be women. So let's call it number of people. Number of people. And this is hours. So that's my hours here. So a typical scenario here. So let's just say it takes 10 people about 10 hours to repair a bridge, say, okay? So 10 people, that's 10 people there, takes them 10 hours to repair a bridge. Well, you know, if you've got, the more people you've got, the quicker or the job will be, like many hands make light work. And obviously, contrary to that, the less people you've got, the more time it will take to do that job. So you notice that if we're down to 4 people, then it could be about 40 hours to do that job. 2 people probably take about 70 hours to do that job, or 80 hours, and so on. And obviously, if you get down to less people, 0 people, well, the job will never be done. So this is what we call an inverse proportion or inverse variation. They vary inversely, meaning that the smaller one value gets, the bigger the other value gets. Okay? So you see, as we get less people, it will take more hours. So that's how inverse proportion or inverse variation works. Now, if you watch my first video, then you'd be familiar with some of the things that I'm going to say to you now. But now we're going to write it slightly different. So we're going to say, let's use the same graph and represent P as people and H for hours. So we're going to say that the number of people varies inversely as the number of hours it takes to build that bridge. Now, if you look at my video on direct proportion first, or direct variation, the new thing that you're going to see here is now, because they're inversely proportional, one goes on top of one of the variables. And as you know, if I have 0 as my denominator, then my whole fraction goes to infinity. So the smaller this gets, the bigger this value gets. All right. So anyway, here we go. Taken again from my last video, we replace the alpha or the proportionality symbol with equal k. So we're going to say P is equal to k times 1 over h. But in short, you can just say P is equal to k over h. Okay? And that's basically how we break it down. All right? Now let's put this into practice by looking at a couple of. So here's my first problem. And it says, if you can read my handwriting, T is inversely proportional to M. If T is equal to 6, when M is equal to 2, find the following. Well, I wouldn't even bother looking at this just yet. We have to sort this little problem here out first. So we know, if we were to plot a quick graph of it, we know that our graph, because they're inversely proportionate, it should look like that. And so they've already given us one of the values. So let's just say this is my T and this is my M here. It says when T is equal to 6, the value of M at this point is going to be 2. So in other words, we'd expect that as T gets smaller, the value of M will increase. Okay, will increase there. All right, that's fine. So we know it looks like that. All right. Let's find out what K is then. So here we go. Let me just choose a nice bright color. So they've told us that t is 6 when m is 2. Well, before we do that, let's sort things out first. T is proportional but inversely to m, so 1 over m. And as I've said just now, we can just replace that with equal to k over m. Now they've given us some information we need to use to find k. They've told us that t is equal to 6 when m is equal to 2. So I'm going to replace t with 6 and m with 2. So that's going to give me 6 is equal to k over 2. I need to remove that 2 from there. So it will need to multiply to be removed. So then k now equals to 12, because 6 times 2 is 12. Now I can rewrite my equation with my value of k. And it's going to be that t is equal to 12 over m. Now this is my main equation. All the other problems I'm about to solve, I have to use this equation to solve that problem. So let's see problem number 1. A. Find t when m is equal to 4. So find t when m is equal to 4. Replace the m with the number 4. So to solve part A, I am now going to say A is t is equal to 12 over 4. And that's because I'm keeping the t, that's what I'm trying to find, and m is equal to 4. Alright, well, you can plainly see the answer straight away, that t is going to be 3. Let's look at question B. Question B is now asking us to find m this time when t is equal to 4.8. Okay, I hope you're very good at rearranging an equation, because you'll need to do that now. Because this time they've given you t as 4.8 and they want you to find m. So you need to do a little bit of rearranging. So here we go. T is 4.8, so I will put that as 4.8 is equal to 12 over m. Okay, so I've replaced my t with 4.8. I'm now going to find m. Well, to rearrange, we need to multiply by m, so we're going to have 4.8 times m is equal to 12. And bearing in mind that I really just want m, so to get rid of this 4.8, I need to divide by 4.8. I will carry on my calculations here. So, dividing by 4.8 makes m equal to 12 over 4.8. Quick whack of that in your calculator if you so desire, but your answer is going to be 5 over 2, or 2.5 if you want it as a decimal, 2.5. So m is equal to 5 over 2. Alright, and that's basically it. Pretty straightforward, so long as you remember inversely proportional means you need to flip. This is our last problem that we're going to look at quite quickly, and yes, it looks like a bit of a monster, but it's not really that bad. Let's have a go quickly and then get it solved. So, reading the question through, we're going to have that q varies inversely. Remember, sometimes I said they use vary, sometimes proportional, doesn't really matter, but q varies inversely with that. The minute they tell us that, I'm going to straight away write down that q, I actually should use what I've been given, so I'm going to use a capital Q. Q varies inversely as 5 minus t. Obviously, replace my proportionality symbol with equal k over 5 minus t. Alright, now let's see what other information they gave us. Well, they said that q is equal to 8 when t is equal to 3. So I'm going to replace q with 8 and replace t with the number 3. So I'll get 8 is equal to k over 5 minus 3. quick bit of working out, 8 is equal to k over 2. Multiply by 2 to get rid of that 2. K will be 16, which means that my main equation is going to say that Q is equal to 16 over 5 minus T. And this is my main equation here that I'm going to use to carry out all my other calculations. All I've done, now that I know that K is 16, go back to here and replace the K with 16. So there is my Q. K is 16, 5 minus T, 5 minus T. All right, let's go solve some problems then. The very first one that we've got over here tells us that they want us to find Q when T is equal to 10. So I'll go back to my main equation. I'm going to find Q. I just need to replace T with the number 10. So Q is equal to 16 divided by 5 take away 10. All I needed to do was replace that T with 10. And that then equals to 16 divided by minus 5. If you want, you can simplify it, but better to just leave it just the way it is. It's fine just the way it is. Okay. All right. When I say simplify, obviously I mean change it to a decimal, but it's fine just the way it is, like I said. Or you can do it as a mixed number. If you did do it as a mixed number, you'll get minus 3 1/5, but you can leave it just the way it is. Okay. Now to go to question B. This time they want us to find T when Q is 16. So I need to replace Q with the number 16 and then go ahead and find what T is. Well, let's do that. So Q is now 16. That equals to 16 divided by 5 minus T. All right. So what I'm going to do is I'll pop this in brackets because I don't want you to get things mixed up. Because now I want T to be on its own. So I'm going to multiply the whole thing by 5 minus T. And if I multiply the whole thing by 5 minus T, I'll get 16 into 5 minus T being equal to 16. And obviously this 16 is that 16. And this 16 at the top is this 16 here because I've just moved all of this all the way over there. Okay, good. My next job is to divide by 16 because I need to get rid of this 16 here. Okay, well, I want the brackets to be open. So I'm going to divide everything by 16. Once I divide by 16, I'll end up with 5 minus T is equal to 1. Obviously, because 16 divided by 16 will become 1. And 1 times the bracket is the same thing, so it wouldn't affect anything much. And obviously I can't just divide on this side and not divide that side, so 16 divided by 16 is 1. Alright, well, you can pretty much see what's going to happen now. What I will do, I don't like the fact that that T is negative, so what I will do is I will move the T over here to make it positive. And then in the same vein, I will bring this 1 on that side. The 1 is positive now, so when I bring it over, it becomes negative. So here we're going to have 5 take away 1 is equal to T. And then I know that T is going to be equal to 4. All right, so that's basically it, guys. That's inverse proportion or inverse variation. I hope that this was straightforward. I hope you understood it. Try out some questions of your own and see how you get on.